In this demo, I will show you how we run MPI applications on the Evolve platform. First, I log in into the dashboard and bring up a Zeppelin instance. Here, I have already imported one of our example notebooks, which you can find in the shared data namespace in the dashboard, right here in the examples, that downloads, compiles and executes one of the well-known NAS benchmarks. The notebook is comprised of several paragraphs and is completely self-contained, meaning that there are no external dependencies. All work is done here through Zeppelin. The first paragraph makes sure the code is downloaded. If it is not, it downloads the benchmark archive and uncompresses it in /remote, which is my home folder in IME Last.fs. The next paragraphs request an MPI virtual cluster from the dashboard and wait for it to be available. Note that I can configure the number of nodes I want, here. This paragraph is written in Python just to showcase the dashboard's Python API, but all this could also be done using shell commands. When the containers with virtual nodes are available, we list them to check their placement, see that they are indeed assigned to different physical nodes. Here the virtual cluster has started 2 nodes, one in node NS60 and one in NS61. The MPI cluster is also visible as a service in the dashboard, here. Then we compile the code, the EP, which stands for Embarrassingly Parallel Benchmark. We compile it in a loop for different number of processes, 2, 4, 8 and 16. This paragraph just dumps the host file from one of the MPI containers. Host files are automatically generated when the virtual cluster is deployed. As part of the deployment, new SSH keys are also generated and exchanged between all virtual cluster nodes. Everything is set now, so it's time to run the benchmark. Again in a loop, we do multiple runs, each with a different number of processes to verify scaling properties. The time for each run is parsed from the benchmark output and recorded in a CSV file. So this is the result for 2 processes, 4, 8, and 16. Finally, we use a simple Python script to plot the results and show how the benchmark runs faster as we scale up the number of processes. Thank you.